module 9 and module 10 is a combination. I already put it together, okay, because the module 9 is the what we call here the content is secret, so I merge it with the module 10. So in the module, this module here, you will learn about that how to do a every R programming by using a C language. Okay, so let's look at why we need to write a C program. Okay, you already learned about the assembly language, but why on earth you're going to use the C program? Okay, so this is the reason, okay, why you are writing in C instead of the assembly. Okay, the first reason here is a C program. Okay, it is easier and less time consuming. Okay, so easy to do a program. Okay, by using a C compared to assembly. In which for the assembly, okay, you need to have a background of your processors. Okay, in which okay, you need to know how many GPIO or general purpose register available in your microprocessor. What are the addresses, okay, for each of the input output ports and etc. But by using a C program, okay, you don't need to know all these things. Okay, it will done automatically by the compiler. Okay, the compiler will telling you, okay, so for this instruction here, it will automatically select the register, either it want to use a register 0, register 1, or etc. Okay, I give you example. Okay, for example here, okay, you going to send a data, okay, from the or you're going to load the data, okay, from immediate value to your register, and then after that you're going to send it to your port. Okay, so what you're going to do is, if you write down in the assembly language, okay, first you need to, okay, let's say port A, okay, you're going to put value 55 in your port A. You're going to send a value for 55 to port A. So what happened here is, in assembly language, okay, what you need to do is, first you need to load this value, since this is an immediate value, okay, and outside value. So in order to do that, what happened here is you need to load this value, okay, 55 to your general purpose register. Okay, for example, now you use the LDI R16OX55. Okay, so what happened? Number 55, you load it to R16. And then after that, by using the out instruction, okay, you can send it to your port A. Okay, so this is how you're going to send a number 55 to your port A by using assembly language. Okay, assume that this port A here is already initialized to be a output port. Okay, but for the C language, okay, what you're going to do here is you just simply write down port A equal to OX55. Okay, so simply write down sending this value here to directly to your port A without using the general purpose register. Okay, so this is what the meaning behind easier and less time consuming. Okay, means that, okay, to do a certain job, okay, assembly language needs to have for this example here, need to have two instruction, but by using a C language you only need to use one line of coding. Okay, and the C is easier to modify and update. Okay, so in terms of portable modification, okay, easy to, for C language, easy to understand and easier to do some modification, and can use code available in function libraries. Okay, for example here, okay, if you're going to do a, a certain function, okay, so you can use the library available in this C library and just use the function in order to use that program. Okay, but for the assembly language, okay, to do a certain function, for example, you're going to do to find out the the area of the circle, for example. Okay, in C language, okay, it has a function to do that, but in the assembly language, there is no function to find the area of the square. Okay, so what you need to do is you need to write down line by line, okay, for the assembly language to perform that operations. And last but not least is C code is portable, and to other microcontroller with a little or no modification. Means that you can use the C program from one controller to another controller without any need of modification. Okay, of course lah, some of the microcontroller, okay, will have this other syntax, so you need to do a little tweak or a little modification on that. Okay, compared to assembly, okay, if you're going to put your program, for example, program A from AVR, okay, Atmega 32, and then you're going to transfer it to the Arduino chip. So you need to do to write down a new program lah. Okay, because the assembly language for AVR is quite different to Arduino programming. Okay, in terms of assembly language, but for C programming, okay, it's quite similar. Okay, so you need to tweak one or two parts, okay, in order to make it works. Okay, so this is why you need to learn the C programming. And moving on to the next slide. Okay, so VRC data types. Okay, let's look at what are the data type available in the VRC. Okay, so this is the data type available in the VRC. Okay, we have the unsigned chart. Okay, so this unsigned chart, every time you come across with the chart, you know that the size is 8-bit. So this one is 1 byte. Okay, since for the unsigned, okay, means that it's a positive number lah. Okay, so the data range is from 0 to 255. Okay, so 8-bit is 1111 1111. Okay, and it started with 0 0 0 0 0 0 0 0. So this is the range lah, started from kosong until 255. Okay, meanwhile, for chart, so this is a signed number, okay, including a positive and negative numbers. All right, so the region, okay, the range of this chart, okay, data type is from -1 to 8 to +1 to 7. Okay, how to, so +1 to 7 is something like this lah. Okay, so 1 1 1 1 and 1 1 1. So this is a +1 to 7, and -1 to 8 is 1 1 1 1 1 1 1 1. Okay, so this is a -1 to 8. Okay, and for the every time you use the sign numbers, okay, so this bit here, bit 8, okay, will be your sign bit. Okay, it will indicate either it's a positive number or negative number. Okay, for the sign bit with the 0, so you know that that one belong to positive value, while the sign bit with a 1, so you know that that one belong to negative numbers. Okay, and then we have the INT. Okay, INT is for the 16-bit data. Okay, so the number of byte is 2 byte lah. Okay, and the data range from 0 to 65,535. If you use the unsigned INT integer, okay, and the range will be from -32,768 until 32,767, and sometimes we have a long. Okay, so the size of a long is 32-bit data. Okay, and the range is from this number to this number here. And sometimes we use a float and double. Okay, float and double also have a 32-bit numbers. Okay, so let's look more detail on this unsigned chart. Why we focusing on the unsigned chart? Because our the AVR, the Atmega 32, the size of the data that you can transfer is 8-bit. So that's why the chart is commonly used when you going to write in the C program. Okay, so unsigned chart is a 8-bit data type that takes a value from 0 to 255. Okay, so this is the, since this is an unsigned number, so it's a positive number, so it can be from kosong sampai 255. And if it is represented by kosong kosong to FF, if you write in hexadecimal. Okay, so and it's a most widely used data type in AVR, of course lah. Why? Because the most of the AVR microcontroller is 8-bit microcontrollers. Okay, so in many situations, okay, for example, if you're going to do a counter, okay, you're going to do a looping, okay, make sure that you use an unsigned chart rather than signed chart. Okay, so every time you're going to do a loops or you're going to do a counting, okay, make sure that you declare, okay, your variable as an unsigned chart. Okay, okay, because counter or every time you do a loop, the counter must be in positive number lah. Okay, there is no such thing, the counter is negative number. Okay, and remember that, okay, so the C compiler use the signed chart as the default unless you put the unsigned in front of the chart. Okay, if you write something like this, okay, you initialize your variable Z, char Z. So what happened here? This is you assign it, okay, you declare it as a unsigned 8-bit data. Okay, so in order to make it as an unsigned, so you need to put the unsigned and followed by char Z. So now it become unsigned 8-bit data. Okay, so this is example lah, how to write a VRC program to send value 00 to FF to port B. Okay, so what you're going to do here is, okay, every time you're going to write a C program, okay, first, okay, you need to have this header here. Okay, make sure that you include this header to your program. Okay, so this include avr/io.h header is actually similar to, okay, dot include, okay, and then m32def dot inc that you already learned in the C program, in the assembly program. Okay, so this is actually the same file lah. Okay, avr/io is similar to m32def.inc in the assembly language. Okay, so if you not include this one here, okay, this file avr/io.h, what happen is every time you're going to use your port A, port B, port C, or any IO registers, you need to know the addresses rather than the label of the IO register. Okay, for the port B, you need to know lah, what is the port B address. Okay, so if you use this, if you include this header file to your program, so what happens here is you can use the label, okay, of IO register. Okay, no need to peningkan kepala, memorize all the memory address of your IO registers. Okay, and so after you include the header, any header that you're going to use, okay, so the second one here is you started with your main program. Okay, your main program can start with int main void. So anything inside of a main program, you can write down here, kat bawah ni. Okay, since this example here, you're going to send a value from 0 to FF to port B. So what you're going to do here is, before you can send out this value 00FF to port B, what are you going to do? Okay, you need to initialize your port B so that your port B become an output port. So how to initialize the input output port? Anyone? Okay, you already learned this one in assembly language. Okay, how to initialize the input output port? Okay, you need to initialize it at what registers? In which registers? In which IO register? Okay, you need to initialize DDRX. Okay, you need to initialize it at DDRX register. So this X here, you can replace with either port A, B, C, and D. Okay, so data direct register. So this data register will determine either you're going to make your port as a port A, make your port as an output port or input port. So every time you're going to use the input output ports, so make sure that this is the most important thing. Make sure that you initialize your DDRX. Okay, so how to initialize the DDRX? Okay, you need to send a certain value lah to your DDRX, either 0 or 1. Okay, if you put 0, why? Okay, your port will become input or output port. If you send a 0. Okay, input. So 0 is input. If you send 1, so it's become output. Okay, so this is what happened lah. Okay, first, unsigned chart Z. Okay, so actually this chart Z here is actually your general purpose register lah. Okay, in assembly language, this variable Z here is actually the general purpose register. Okay, so here, okay, DDRB equal to OXFF. So what happened here? You initialize all the port B as a output port. Okay, so I put here. Okay, DDRB sama dengan OXFF. So what happened here? Okay, so this is your port B. Okay, it have a 8-bit data. Okay, and this is your DDRB. Okay, since your DDRB get this value FF, what is FF? 1111 1111. So now you're telling that, okay, so this one here, all the port, okay, from PB0 until PB7 here, okay, you make it as a output port. Okay, so all of these become your output port. Okay, because why? Because you send 1 to this, started from PB0 until PB7. So of course lah, you can mix, okay, to have a few port as an input port and a few port as a output port. Okay, but it depends on the value that you're going to send at this bit here. Okay, the value either 1 or 0 will determine that either your pin kat sini become your input or output ports. Okay, once you, in this case here, okay, once you already assign, okay, or declare, initialize your port as a port B as output port. So next what happen here, okay, by using a for loop, because you're going to send 0, 0 to FF, correct? Okay, so you're going to do a counting sequence lah, okay, started from 0 until 255. So that's why you use a for loop. For Z equal to 0, Z is less and equal to 255, Z plus plus. And what happened here? So every Z here, you will send it to your port B. So your port B will increase, okay, the value of your port B will increase according to the value of your Z. And it will keep repeating. Okay, so this is how you're going to write the C program. Okay, include the header file and started with your main program. Okay, if you have the subroutine or you're going to have a subroutine or function, then you need to initialize the subroutine and function, okay, in between here, in between the header file and the main program. Okay, later we will see on that in the next slide. Okay, and then we have the sign chart. Okay, sign chart is a 8-bit data type that use, okay, your bit 7, the MSB bit, the most significant bit, to represent either a positive or negative value. Okay, so this is your data. Okay, it's a 8-bit data. Okay, and this is a bit 0 and this is a bit 7. Okay, so this bit 7 here will become your sign bit. Okay, okay, it will represent either is a positive number or negative number according to this value of your sign bit. 0 is a positive, 1 is a negative value. Okay, and due to this bit 7 become your sign bit, so only 7 bit here from bit 0 to bit 6 become the magnitude. Okay, so that's why the value, the range of this sign chart is from -1 to 8 until +1 to 7. Okay, +1 to 7 is 1, 1, 1, 1, 1, 1, 1, and this is a 0. So that's why it's a +1 to 7, and -1 to 8 is, okay, this one is 1, and the rest is also 1, okay, and it becomes -1 to 8. Okay, and again, okay, C compiler use the sign chart as the default. Okay, so this is an example. Okay, you're going to write an VRC program to send a value from -4 to +4 to port B. Okay, again, you're going to use a port B, okay, to represent this -4 to +4. So what you're going to do here is, okay, first, include the AVR header file, okay, which is avr/io.h. And then after that, start with your main program. Okay, and this one here, okay, you see here, okay, you initialize this mynum variable as an array of data. Okay, char mynum, and you have a bracket here. So this is what happened here is you initialize your mynum as an array of data, in which inside of this array you store this value. Okay, -4 until +4. See, -4, -3, -2, -1. So this is what happened. Okay, so this is mynum. Okay, it has an array of data. Okay, so this is array 0, 1, 2, 3, 4, 5, 6, and inside of this array here, okay, you store -4, -3, -2, -1, 0, 1, 2, 3, and 4. Okay, so this is a 7 and 8. Okay, and after that, initialize the variable z as an unsigned character. Okay, why variable z you declare it as an unsigned? Because this variable z you're going to use it as a loop counter. Okay, so that's why every time you're going to use it as a loop counter. Okay, initialize it as a unsigned value. Okay, then ddrb oxff. Okay, initialize your port B as an output port. Okay, here output. So need to initialize your port B as an output port. And from here, for z equal to 0, z smaller and equal to 8, z plus plus. Okay, you have 8 data here. Okay, from you have 9 data from 0, 1, 2, 3, 4, 5, 6, 7, and 8. And so it will keep repeating. And you see here, port B equal to mynum z. So what happened here is, so when port B sama dengan mynum, okay, let's say your mynum value is 0. Okay, when mynum value is 0, so port B will take this value, -4. Okay, when mynum number is 1, so this value will be sent to your port B. And when mynum number is 8, so +4 will be sent out to your port B. So this is how you're going to use an array of data. Okay, to display this positive and negative numbers, okay, to your port B. Okay, so this is for the signed chart. And then we have the unsigned INT. Okay, so unsigned INT is a 16-bit data type that takes a value from 0 to 65,535. Okay, which is started from 000 until FFFF. Okay, so INT 16-bit data. Okay, the maximum is from 0000. So if 16-bit data, so you have 2 byte lah. Okay, lower byte and higher byte. Okay, so lower is starting from 0 and higher the maximum number is FFFF, which is the 65,535. So in AVR, unsigned INT used to define the 16-bit variables such as a memory address. Okay, so this unsigned integer will be addressing your memory address. Okay, remember back your address. Okay, so this is your data memory. Okay, data memory you can divide it into 3 bahagian. Okay, which is the first on top here is your GPR, general purpose register. Okay, you have a 32 GPR. Okay, which is the starter address started from 0000 until berapa ni? Can anyone tell me what is the end address of your GPR? 00? Anyone? Okay, you need to remember this one. Okay, because this one will always ask in the final exam or test. Okay, so 001 F. Okay, then you have a IO register. How many IO register you have in ArcMega 32? Okay, you have a total of 64 IO registers. Okay, which is started from 002 F until 005 F. And then you have a RAM. What is the size of your RAM? 2 kilobyte. And what will be the starting address and end address? The starting address of your RAM is 0060 until, okay, your RAM end. What is your RAM end? Okay, you need to know what is your RAM end. Anyone?
085F.
Okay, 085F. Okay, so your RAM end is 085F. Okay, actually you can calculate this one here using what we call here, using a equation. Okay, using a formula, which is end address sama dengan start address plus with your size minus 1. Okay, the size must be in a byte lah. Okay, so start address, contoh lah, you have a 32. Okay, you're going to find out what is your end address of GPR. GPR, the starting address is started at 0000. And size, what is your size? 32 byte. Okay, minus 1. Okay, of course lah, this 32 here, you need to change to hexadecimal. Okay, so the hexadecimal for 32 is 20. 20 minus 1, you will get 1 F. Okay, you need 20, yeah, not 2F, sorry, 20. Okay, the IO started at 0020 until 005. Okay, then moving on to the next slide. Okay, the signed INT. Okay, the signed chart. Okay, so please do a correction here. So the signed INT is a 60-bit data type that use the MSB. Okay, so every time it's a sign, so the most significant bit will become your signed bit. Okay, to represent either negative or positive value. Okay, so those on this 50 bit from the magnitude of signed number giving us the value from this number here to this number. Okay, and this is the another itulah or another data types. Okay, so INT, okay, which is system dependent. Okay, the range of for the byte and range min and maximum is system dependent. For the AVR, Okay, every time you use a INT, it is a 16 bit. Okay, and then you have a char. Okay, sometimes you can put something like this. Okay, so this is another way lah to write down the char data byte, which is underscore underscore int8. Okay, so int8 means that it's a 8-bit data. Okay, and it is the range lah. Okay, ataupun unsigned char. Okay, which is what we learned earlier. Okay, if you short int and etc. Okay, and this is the data type. Okay, that commonly used nowadays. Okay, by using the ISO C99. Okay, in which you no longer need to remember the char, the long, the int, what this data type, what is the byte of the data type represent of. Okay, why? Because by using the ISO C99 data type, okay, so every time you look at this int8 underscore t, so you know that it is a unsigned integer 8-bit data. Okay, if you use the uint, okay, sorry, this is a signed integer 8-bit data. If you uint8 underscore t, so this belong to unsigned int 8-bit data. Okay, so the number of bit represented by these numbers here. Okay, if your int 60 underscore t, so this is a signed 16-bit. uint under 16 underscore t, so this is unsigned 60-bit. Okay, for the 32-bit, okay, you can use this one here for unsigned number. For signed number, unsigned number, you can use the uint 32 underscore t, and this is for the 64. Okay, so this is the simplest way lah. Okay, to differentiate between the 8-bit data, 16-bit data, 32-bit, and 64-bit data. And to use this data type, ISO C99 data type, okay, you need to include this header here. Okay, include stdint.h in your program. Okay, and that is for the data types. Any question up until here for the data type? Okay, one of your question asking, okay, Dr. for Iowa, okay, betul. Saya dah baiki dah tadi. Okay, it start from 20 not to F ya. Okay, if no question, then we move on to the next slide. Okay, logic operation in C. Okay, so in C, we can do a data processing, and you can use a arithmetic processing. You can do the logic processing. Okay, then you can do the data shifting. Okay, for that, okay, which is similar to assembly language. Okay, so let's look at what are the symbol for this logic operation in C program. Okay, so this is a bitwise operator for the logic operation in C. Okay, for the C program, we also have the logical AND or exclusive OR and inverter. Okay, and the symbol here for these operators or for logic operation for the logical AND, okay, you can use this ampersand symbol or this AND symbol here. Okay, for the AND, for the logic ANDs, and for the logic OR, okay, you can use this vertical, okay, the long vertical line symbols here. Okay, for the exclusive OR, you can use this symbol here to represent the exclusive OR. And for the inverter, every time you see this symbol tilde, okay, so it means that you're going to do the inverting logic operations. Okay, and the output from this logic operation is similar what you learned earlier. Okay, for logical AND, okay, so the output of the logical AND will 1 if both of the inputs are 1. Okay, otherwise the output will be 0. Okay, for the logical OR, the output of the logical OR will be 0 if both of the inputs are 0, and it will be 1 if one of the input have 1. Okay, for the exclusive OR, okay, if both input are same, okay, similar, okay, the output will be 0. If both input are different, then the output will be 1. Okay, and for the inverter, of course lah. Okay, it will inverting your input. If your input is 0, then the output will be 1. If your input is 1, then the output will be 0. Okay, so let's look at this example, 712. Okay, so run the following program on your simulator and examine the result. Okay, so include hashtag include VRI over the hash. Okay, so this is the standard lah. So every time, okay, if you're going to write down the C program, make sure that you write this header. Okay, sometimes it will give you 1 or 0.5 marks. Okay, just simply write this one here. Okay, and start with your main program. Okay, and this one here, so every time you see the DDRB, DDRC, DDRD, so you know that this one you're going to initialize the IO port. Okay, since in this initialize port here, okay, you see you send the FF, you know that this port B, port C, and port D, you're going to make it as a output port. Okay, and now, okay, let's look at the port B. Port B equal to OX35 and OX0F. Okay, so what happened here is you're going to find out what is the port B value. Okay, port B sama dengan 35 and with 0F. Okay, so what is the output of your port B? Okay, so what you're going to do here is, okay, every time you come across with the logic operation, okay, and I advise you to change, okay, this hexa value to binary numbers. Okay, so 35 by using the add 4 to 1 method. Okay, 35 is 0, 0, 1, 1. 5 is 0, 1, 0, 1. Okay, 0F is 0, 0, 0, 0. F is 1, 1, 1, 1. And then you do the logical AND. Okay, so 1 with 1, you will get 1. These are 0, 1, 0, 0, 0, 0, 0. So the port B will have this value, which is 0, 5. Okay, so this is, okay, you're going to do the logical AND, okay, between this number and this number. Okay, by using the C program. Okay, if you're going to use do the same thing using the assembly language, what you're going to do? Okay, first, you need to load 35 and 0F to your general purpose register, correct? And after that, by using the OR operation, then you can do the ORing. AND operation, you can do the ending. After you get the AND, okay, ending, after you end this value here, then after that, okay, what you're going to do is you need to get it to your output. Okay, let me show you if you're going to write down in the assembly language. Okay, for this port B sama dengan 0x35 and with OX0F. So what you're going to do? Okay, first, okay, initialize your port B so that you become output port. So what you need to do is, okay, load I R16 0xFF out DDRB R16. Okay, so port B sama dengan output. Okay, so you need to have 2 lines of instruction. Okay, compared to C programming, only need 1 line of C coding. Okay, next, after that, now you're going to do this here to end this number 35 and OF and put it to your port B. So what you're going to do? Okay, load I R17. Okay, you need to load lah this value to your register first. Okay, OX35 and load I R18 OX0F Okay, after you load this here, then after that you can do the A and D R17 R18. Okay, so this is what happened ya. R17 sama dengan R17 to a logical and R18. And next, then the output from R17 you need to send it to your port B. So out port B R17. Okay, so how many lines do you need? Do you need to perform this AND operation? Okay, 1, 2, 3, 4, 5, 6. Okay, 6 lines, including the initials of port B. Okay, but for the C programming, okay, you need to have 1 and 2 lines here to do the logical AND for these two numbers. Okay, next, port C sama dengan OX04 and with a 68. So what are you going to do? Okay, so first thing first, okay, change this value to the what we call to binary numbers. Okay, so 0, 0, 0, 0, and 4 is 0, 1, 0, 0. Okay, 8, 4, 2, 1, 8, 4, 2, 1, and then 68 is 0, 1, 1, 0, 1, 0, 0, 0. Do logical or 0, 0, 1, 1, 0, 1, 1, 0. So you will get okay, port C sama dengan D is a num and D is 8 tambah 4 is 12, 12 is A, B, C. So port C equal to 6, C. Okay, and the port D, okay, so this one you can do it by yourself and get the port B. Okay, so this is the symbols lah, used for the logic operator in C programming. Okay, next we look at another examples here. Okay, you are going to write an VRC program, okay, to toggle only bit 4 of port B continuously without disturbing the rest of the pin of port B. Okay, what are you going to do here? Okay, you have a port B. Okay, now you're going to toggle bit 4 only. Okay, cause 0, 1, 2, 3, 4. Okay, this bit only. Okay, you're going to toggle it from 0. The next cycle, it become 1. And next, it will become 0 again. And it will keep repeating continuously. What about the rest of the bit? The rest of the bit, the value, okay, will remain. Okay, the value is remains. Only this bit is changed. So how to do that? Okay, to do that, okay, first you include this file here. Okay, again, include this io.hshader file and started with your main program. Initialize your port B as an output port. Okay, since this is a continuously, okay, for the continuously, okay, you need to use the while one. Okay, while one means that it will do, okay, it will run the while loop continuously or endlessly, okay, until you stop the program. Okay, so that is by the meaning of continuously. Make sure that you use the while one. Okay, so here, so what you're going to do here is port B sama dengan port B, okay, or with 0B00001 00000, okay, which is here, okay, whatever value of port B, okay, so port B, yeah. So let's is this is your port B. Okay, let's I put the port B, initialization of port B is 0 lah. sama dengan kosong. So kosong, 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 kosong. And then you're going to OR with this value here. 0, 0, 0, 1, 0, 0, 0, 0. Okay, you see, after you do the ORing, so what happened? Okay, bit for change. Okay, while the remaining of the bit, okay, follow the previous value. Okay, the no change. Okay, so that is what happens if you do something like this. Okay, port B or with the value that you're going to set. Okay, the bit that you're going to set. And then after that, port B equal to port B and with this number here. Okay, so what happened here is, okay, so this is the current value of your port B. Okay, then now you're going to end with this value. So 1 1 1 0 1 1 1 1. Okay, you see here after you perform this operation. Okay, so this one become 0 0 0 0 0. Okay, so you see bit for change, but the remaining of the bit remains. Okay, so this is what this is the meaning behind without disturbing the rest of the pin. So without disturbing the rest of the pin, so make sure that every time you're going to do it, okay, make sure that you need to include this port here, okay, uh, in your coding as well. Okay, and then close your while loop and close your main program. So any question up until here? Okay, so this is for the logic operation. Okay, we have another example. So I think, okay, I stop here. Okay, and then this slide here will continue in the next meeting. Any question up until here? Ada soalan tak?